All right, I'm gonna try this again because in the last video I demonstrated this and the ball it came out and landed like right here, but I had the camera so close you couldn't see it come out of the top of the tube. So what I'm gonna demonstrate is force can transfer through an object on the y-axis. So you got your y and your x, and I think everybody should know what graph that is. And what I'm gonna demonstrate is that this is going to accelerate up into here, and it's going to knock that top ball up and out of the tube to prove force on the y-axis. Now it might take a couple tries, just to let you know. The first try might not work. So see how it slipped out and didn't really come out of the tube. Let's try it again here. I gotta hold that, get it all the way like down in here, and let it go. Ooh, it knocked two of them out. Did you guys see how it knocked two balls out? That was actually a really good explanation of proving force on the x-axis. Just like how I took the spring and I pulled it, or excuse me, on the y-axis. Just like how I pulled the spring back on the cradle and it hit the pool ball and that thing, and it rolled to like over here. But as you can see, I just demonstrated force on the y-axis. So this natural force isn't there because the balls were up against, gravity was holding it down, and the only thing that demonstrated force on the y-axis, I believe, is Hooke's law of elasticity, spring mass. And then when you get to elasticity in the physics book, you're going to find that this is your spring, your mass on a spring mass system, but on the y-axis. But it says that something about momentum, and this shouldn't have done what you just seen it do. So there you go. Cool.